Okay, let's look at these questions. So the first one, question 40, is looking for you to explain a number of things. And really in each case you should be giving a FAPSO answer. So the first one says you cannot push your thumb through a wooden desk, but with the same force you can push a drawing pin into the wood. So in this case you would say, although the force is the same, the area of your thumb is much larger than the area of the tip of a drawing pin. Therefore, the pressure on your thumb is much less, so it doesn't go into the wood. Okay, your answer doesn't have to exactly match mine, but you should be able to tick off force is the same, area of your thumb is bigger, and pressure therefore is smaller. Okay, so you can make a comparison there. Part B, when a fireman rescues a dog which has fallen through the ice in a frozen lake, he puts a ladder on the ice first and then crawls out to the dog on the ladder. Well, the force in this case is the weight of the fireman is spread over the much larger area of the ladder, so the pressure is smaller, therefore he doesn't fall through the ice. Okay, so once again, it doesn't have to match mine exactly, but you should be able to tick off F, A, and P there. See, a chieftain tank will not sink into soft ground. A chieftain tank is just a big military tank. Although the weight of the tank, that's your F, is large, the force is spread over the very large area of its caterpillar tracks. Okay, so if you think about a tank, they have really large caterpillar tracks that spread the area, or spread the force over a really large area. Therefore, the pressure is small, so it doesn't sink into the ground. And D, a carpenter will sharpen his chisel before he starts work. So a chisel, if you're working with wood, a chisel is a little, drawing that too high up, let's draw it down a little bit lower. So piece of wood, chisel has a sharp tip in it, like that, and a little handle, and you hit that handle with a hammer, and that force is transferred to that tip. Okay, so you can kind of chisel away the wood, you can kind of chop off little bits of wood. So a carpenter will sharpen his pencil before he starts work, so that the force created by the hammer will be spread over a very small area if the tip of the chisel is sharp, creating a large pressure, so it will chisel the wood more easily. Okay, so anytime you're writing a FAPSO answer or any descriptive answer on pressure, you should be thinking about FAPSO, because that way you can tick off all those things and you'll almost guarantee yourselves the marks in the question. So question 40 is all about FAPSO. The next questions are more about the calculations. So question 41, we just do the same thing we always do. Girl weighs 600 newtons, so that's our force. Even though it says weight is a force, it's measured in newtons. And the area on both her feet, I'm assuming that's combined, is 150 centimeters cubed. So we don't have to square it, we don't have to double that or anything. Calculate the pressure. Do P equals F over A. P equals 600 divided by 150. P equals 4. Make sure your unit's consistent. Newtons divided by centimeters squared. Question 42. A power washer can produce a fine water jet with a force of 56,000 newtons, very large force, and that acts over a very small area of 0.005 meters squared. Calculate the pressure. So we can do pressure equals force divided by area. P equals 56,000 divided by 0.005. Type that into your calculator, and that gives us 11,200,000 newtons per meter squared. Or we could write that as, because it's equivalent unit, pascals. Same meaning as meters per second squared. 43. A large metal box is, let's draw our box and label our diagram. So it's 0.8 meters long 0.5 meters wide. Let's make this one 0.5 meters and 0.4 meters tall. And it tells us it has a weight, so that's our force, of 320 newtons. Calculate the area of each of its faces and hence find the maximum and minimum pressure which the box can exert in the ground. So we kind of have three faces here. So that face there has an area, length times breadth, of 0.4 times 0.8, which will give you 0.32 meters squared. This face here will be 0.4 by 0.5, which is 0.2 meters squared, and this top face is the biggest area, so it's an area of length times breadth of one side's 0.8, the other side's 0.5, so it's an area of 0.4 meters per second squared. So I want to calculate the pressure, which is force divided by area, but first of all it says we want to calculate the maximum. So let's work out the maximum pressure, and the maximum pressure is going to occur when we have the smallest area. So the force is 320 in each of these, but the smallest area we've got is this one. So we then do 320 divided by 0.2, and that gives us 1,600 newtons per meter squared. To work out the minimum pressure then we do force divided by area, but the minimum pressure is going to occur when we have the biggest area, which is this one here. So if we laid it down, the way it's sitting there, actually it's sitting on a face equivalent to that blue face, so it will be producing this pressure the way we've drawn it. So we divide that by 0.4 and it gives us a pressure of 800 newtons per meter squared. Okay.